Assalamualaikum warahmatullahi wabarakatuh. Welcome aboard on our FYP1 presentation. Our project ID is 902R with the title Digital Forensic on Health-Related IoTs. Before we begin, allow us to introduce ourselves. My name is Muhammad Husin bin Ahmad Rumaizi, 1813165, and my partner Muhammad Azrul bin Noor Azmi, 1811839. We are supervised under Associate Professor Dr. Normaziah binti Abdul Aziz. We do know, in current days, where healthy lifestyle has become a trend in everyone's life, health-related IoT devices such as fitness tracker are becoming more famous as people want to track their health record, such as number of steps, heart rate, jogging pace, and so on. With people wearing all the time in daily lifestyle, there are potential that the device can be used as a digital evidence in court. Therefore, this research will be on studying the architecture of health-related device, locating resources of evidence, and acquiring the evidence itself. With this in mind, the problem statement for this experiment are as follows. In modern world, we cannot rely on conventional evidence. Instead, digital evidence is equally as important. Thus, the lack of techniques in extracting all valuable evidence in devices will delay in solving cases. Health-related IoT devices can bring a whole new perspective to the forensic department to find valuable information regarding the cases that involve human anatomy. Secondly, health IoT device will always be evolving with new features such as sensors that record the data about user activities. Hence, new tools and techniques are needed, as there is no one-size-fits-all tools that is used for analysis, even in the conventional digital forensic. Next, our research objective is to prepare a general rule in digital forensic investigation by providing calibration of where to identify evidence in terms of IoT devices. Secondly, our aim is to determine the forensic readiness of IoT devices to ensure the process of digital forensics is fully prepared and well equipped. The third one is we want to demonstrate the digital forensic processes using health-related IoT in a controlled environment. Moreover, as a result of this research, we hope that important evidence, information, and data can be obtained in forensic investigation so that it can help with tracking criminals or defending the innocent. Secondly, we also hope that the information from health-related IoT devices can act as a vital aspect in a forensic investigation. The first research related to our work proposed that the readiness framework before conducting IoT forensic investigation. It also emphasized the importance of having the forensic readiness in place before conducting the investigation, as it is complicated due to the various interconnectivity among heterogeneous IoT devices. This forensic readiness is required to ensure the stakeholder is prepared and to fully support the IoT incident. Secondly, the next paper is regarding whether the digital health data from devices can be used as digital evidence. The answer is yes. From this paper, we gain important knowledge such as the structure of data in SQLite. So from that, we know what data and in what extension to find in our project. Lastly, the third paper is a very useful one, as it talks about methods and techniques in extracting and analyzing the evidences. Although the IoT devices is not the same, but knowing the tools used in acquiring the device's data and how to do it is like a light at the end of the tunnel.
Moving on to the next topic, our type of research that we implement in our research is applied research. This means that the project we are doing is designed to identify the solutions to specific problems. In this case, it is forensic investigation on health-related IoT devices. We want to find solution in the forensic department that want to obtain more evidence using other than conventional devices like phones and computer. These issues also meant to offer knowledge that is applicable in real life situations, just like I explained before. The results of this project can be implemented in a real forensic environment that requires extra evidence to solve cases. Next, I will explain on how our methodology of our research that we are conducting. The proposed model that we are used as the guideline for the digital forensic process were outlined by the National Institute of Standards and Technologies Special Publication, Issue 886, Guide to Integrating Forensic Techniques into Incident Response, that are based on 4 phases, which are collection, examination, analysis, and reporting. The collection phase refers to the collection of digital evidence that are related to the incident. Examination involves assessing and extracting every piece of information from the collection phase to be analyzed in the next phase called analysis phase. Analysis phase refers to the analysis of the information from the examination phase and draw its conclusion whether the evidence is relevant to the case or not. Finally, after we done all the phases that require technicality and tools, we need to prepare a report presenting the information resulting from the analysis phase. So these are the devices and tools that are needed for our project. We are using all Android-based devices as there are many Android users in the market than Apple devices. For the smartphone, that will add as the bridge for the device. The fitness tracker is Samsung Galaxy A03 that comes with Android 11. Android 11 has pretty high-end security, makes it difficult to root in the first place. The fitness tracker consists of Huawei Band 6 and Samsung Galaxy Fit 2. The tools that we use for our implementation are Android Debug Bridge or ADB that is used to interact with the mobile phones and launch privileged commands such as backup and imaging. For the main workstation, we use a laptop with Linux operating system, as we want to utilize any related command for forensic purposes. Android backup extractor command is used to change the backup file, the AB extension, to TAR extension, so that we can use it for the extraction purposes. FTK Imager is used to analyze image files from the DD command that I will show you next slide, and the Wireshark to analyze the captured data packet. Next, we will move to the implementation part of our project. The data acquisition process involves 4 main phases, which are prerequisite, imaging, getting the hash value, and data extraction. So before we move to the main part of getting the data, we need to enable the developer option for each device to allow debugging process with the laptop. It is also important to root the device, as downloaded device may have hidden files and restricted access to the device. Lastly, we need to install Android ADB using the Android Studio and a USB cable for debugging purposes for the device. Imaging can be performed using the DD command inbuilt in Linux command to perform backup and hashing with a selected algorithm, which is in our case is SHA-256, that makes it more secure to make changes to the acquired files. The full backup option will appear at the phone to confirm the backup. We can see after we run the command, a backup file will appear as AB files, and we can use the backup extractor, Android backup extractor, to convert the AB files into the TAR archive to be extracted for the next phase. After we got the image files with the backup that we have done in the previous slide, we can perform data extraction by using the FTK Imager to open the DD files and to be analyzed for the next phase. Next, we move on to the analysis of evidence. Non-volatile data can be extracted using the previous method that I have explained. The main part of extracting the non-volatile data is getting the database files that store information in form of SQLite files. Next, all data can be accessed using the logcat command in ADB terminal. If the phone was still powered on, we can perform logcat command with find string command of the name of the app to find more information. And network analysis can be done by using the TCP dump to capture the PCAP files for further analysis using Wireshark. This is the one information that we find using the logcat command that contains sleep, start time, and end time.
Lastly, on our implementation is the reporting phase. This final phase is important as detailed and thorough reports are required to ensure that everyone can understand the paper even after 10 years. The quote by Louis Fryer, the FBI, 50% of FBI cases involve digital evidence. With technology being a part of everyday life, soon all trails of activities will be electronic based. To conclude, the project is important, especially in modern world, as it is impossible to separate human and technology. For future works, more devices needed to be investigated as every device has their own data structure. That's all. Thank you.